Our first section in Trig is called section 1.1, and it involves ideas about angles, degrees, and special right triangles. So this should all be reviewed from probably your geometry class. And the first bit of our notes is referring to some vocabulary. So an angle is formed by two rays with the same endpoint. The common endpoint is called the vertex. And the angle that we generally measure is between the two rays. The terminal side would be the landing position of the direction of which you're measuring. So right here from O to A, that's ray OA, that's our initial side, and since we're reading this particular angle upwards, ray OB is our terminal side. Remember, we can name angles, in that case either BOA or AOB, as long as the vertex is always in the middle. Now for our trig class, we're going to refer to angles that measure in the counterclockwise direction as a positive angle, and if they measure in the negative direction, if they go in the clockwise direction, that's a negative angle. So some more vocabulary is how we're measuring within the degree unit. We're going to learn about another unit of measurement for angles later on, but for now it's degrees. If we rotate one full circle, one revolution, that's 360 degrees. Remember from geometry, this is what a 90-degree angle looks like, a right angle. A straight angle would be 180 degrees, and usually you refer to that as a line, but that's a straight angle. An acute angle is any angle less than 90. An obtuse angle is an angle greater than 90. And then some more vocabulary from geometry. Two angles that add up to the sum of 90 degrees are called complementary angles, and two angles that add up to 180 degrees are called supplementary angles. So this is all review from geometry still. The first question says, give the complement and the supplement to each angle. So let's look at part A. If I'm trying to find the complement, remember it's the angle that would add in total to 90 degrees. So if my angle is 40 degrees, his complement is 50 degrees. And his supplement, they would have to total to 180 degrees, so our supplement is 140 degrees. For part B, 110 degrees is already obtuse, so there is no complement to that angle. And our supplement would have to add up to 180, so that would be a 70-degree angle. And then in part C, we are going to generalize for any angle theta. In trig, we like to use theta for angle measurements as opposed to some other variable, so get used to that. The complement would be 90 minus whatever the initial angle was, and our supplement would be found by taking 180 and subtracting the initial angle. A right triangle has to have one right angle, and Pythagorean Theorem should come to mind anytime you see a right triangle picture. So remember, a squared plus b squared equals c squared is your Pythagorean Theorem, and the important part about the Pythagorean Theorem is that a and b are your legs, and c is always the hypotenuse. So we also could write this as hypotenuse squared equals leg squared plus leg squared. So when I look at example 2, they want me to solve for x. This is a Pythagorean Theorem problem, but it's a little more complicated than the ones we saw back in geometry class. So our legs are x and x plus 7. So if I take x and I square it, and then x plus 7 and square it, it's got to come out to my hypotenuse squared, which is 13 squared. So we end up with some quadratic algebra. X plus 7 squared is x plus 7 times x plus 7, don't forget about that, equals 169. So let's see, we've got x squared plus, whoops, ignore me, plus another x squared, and then we have 14x in the middle, and plus 49. And remember from algebra, whenever we want to solve a quadratic, we have to bring everything to the left and set it equal to 0. Usually is the way we solve these. So I'm kind of running out of room, so I'm going to write down here. We end up with 2x squared plus 14x, and then when I subtract 169 over, we get minus 120 equals 0. Now generally you guys solve quadratics by factoring, so I am going to go ahead and divide everybody by a 2, which is a common term that I can take out by dividing in this case. So we have x squared plus 7x minus 60 equals 0, and then generally you guys would solve this through factoring. So let's see, that would factor into x plus 12 and x minus 5. So notice, if I tried to solve these, x plus 12 is going to result in a negative answer, So I'm going to go ahead and cross that off because I know this is supposed to be the length of a side of a triangle, and there's no way it's going to be a negative 12. So my answer here is that x must equal 5. And all they wanted us to do in this problem was solve for x, and that is the answer. I'm going to warn you, on your homework, they usually don't make you stop at solve for x. They'll usually also say solve for x and find the length of the 3 sides of the triangle. So be prepared to go back and do that. The next example is referring to this diagram down here. And it's, let's see, a forest double chair lift, has a vertical rise of 1,170 feet, and the length of the lift itself is 5,750 feet. So the diagram is already labeled for you. The question is, find the horizontal distance. So they want us to find this leg here. So we're going to set up Pythagorean Theorem again. X squared plus 1,170 squared equals hypotenuse squared. And then I don't have my calculator handy, but I've already worked this out. I'm going to subtract 1170 squared over here. And then whatever that answer happens to be, I need to square root it still. So don't have my calculator handy, but after I subtract and then square root, my answer comes out to 5,600. And I'm going to round it up to 30 feet because the directions in the problem say to the nearest foot. Didn't come out to exactly that, but that's what they wanted. Usually your application problems are going to result in decimals, and you want to think appropriately for how you want to show your answer. Okay, the 30, 60, 90 triangle is another concept from geometry that we need to remember. So in a 30, 60, 90 triangle, there's a 30-degree angle, a 60-degree angle, and a 90-degree angle. And this is the formula, or the patterns, that we're going to recognize in a 30, 60, 90 triangle. So the little leg we're going to call t, or some variable. The hypotenuse is always double the little leg. And then the medium leg, the one that's across from the 60, is whatever the little leg is times the square root of 3. So the question on example 4 is, if the shortest side of a 30, 60, 90 is 5, find the other 2 sides. Well, I always like to have a picture, and even though my pictures aren't pretty, I'm going to draw it anyways. So I'm going to label that this is the 30 and this is the 60. So the question is, if we know the shortest side is 5, so the shortest side would be down here. Now if I look at my pattern, the 5 is now the t. So the other side would be double that, so he's going to be a 10. And then the medium side is whatever the short side was times the square root of 3. And in this case, we don't want a decimal. In Trig, when it's not an application problem, I always want the most beautiful ACT style answer that I can get. Example 5 has a ladder leaning against a wall, and they do give us a picture, but I don't like to see these really artistic pictures. I like to just see the triangle. So I'm going to redraw it over here, where this is the wall and this is my ladder leaning against it. Again, not pretty, but that's okay. The top of the ladder is 4 feet above the ground. So from the ground to the top of the ladder, that's 4 feet. And then the bottom of the ladder makes a 60-degree angle with the ground. So down here at the ground, this is my 60-degree angle. Since this is obviously the 90, that leaves this guy to be the 30. The question is, how long is the ladder? So they want us to figure out how long the hypotenuse is. We can't do Pythagorean Theorem because we don't have the other side, so we have to think about the 30, 60, 90 relationship. Well, this 4, which I'm going to circle, kind of equates to the pattern t square roots of 3. So what I'm going to set up is a little side problem that says 4 is supposed to be in the form t square root of 3. And then the next thing I wanted you to do is solve for t. So we would divide both sides by square root of 3. And right now I have t equals 4 over square root of 3. But remember, from algebra and geometry, we're not allowed to have radicals in the denominator. So we're going to make this a better answer by rationalizing the denominator, square root of 3 over square root of 3. And I end up with 4 square roots of 3 over 3. Now I got to be a little careful. All I just found was t. And remember, t is the short leg. He's that guy. We want to know the hypotenuse. And the pattern for the hypotenuse says that he is double the short leg. So I'm going to take my short leg, which is 4 square roots of 3 over 3. And I'm going to double him, also known as multiplying by 2. And that gives me 8 square roots of 3 over 3. And that is my final answer. Oh, I didn't answer that question. I did not read that right at all. Ignore me. The question said, that's a 3. How far is the ladder from the wall? they didn't want to know that at all. They wanted to know t, so I could have stopped a long time ago. My answer is 4 square roots of 3. Alright, moving on. Sorry about that. A 45-45-90 triangle has its own pattern, and this one was a little easier to remember because it's an isosceles triangle. So the two legs are going to be the same measurement, and then the hypotenuse is whatever the leg is times the square root of 2. So an example that they give us here in number 6 is that a 10-foot rope connects to the top of a tent pole, and it goes to the ground. So here's my tent pole, and then here's the rope going to the ground. Whoops. And it makes a right triangle because the tent pole and the ground are going to be perpendicular. The rope makes a 45-degree angle with the ground. So down here I'm going to draw this as 45 degrees, which makes this also 45 degrees because a triangle has to add up to 180. Find the length of the tent pole. So they want us to figure out this. Now there's one more clue I didn't label yet, and that was that the length of the rope was 10 foot. So that's going to be the hypotenuse of our triangle. So now if I look at my pattern for this triangle, the hypotenuse should be in the form t square roots of 2, but my hypotenuse is in the form of 10. So I'm going to set up a little side problem that says t square roots of 2 equals 10, and I'm going to solve for t, or in our case it should have been an x. Let me erase that and make that an x. Alright, so we're going to divide both sides by the square root of 2. And you might remember doing this a lot in geometry. 10 over square roots of 2 is not an okay answer. Again, we have to rationalize. And that's how we're going to get 10 square roots of 2 over 2. But we're still not done. Because the whole numbers 10 and 2 can reduce, my real answer is x equals 5 square roots of 2. That is the length of the tent pole. And that concludes the lesson on 1.1. There's a rather large book assignment that follows this. So make sure that you are looking ahead into your schedule and making sure you have enough time to finish this for the homework check.